Hello everyone, today we're going to be talking about sections 13.6 and 13.7, which is going to get us into what we call right triangle trigonometry. So far we've been talking about some right triangles and dealing with those special right triangles, specifically a 30-60-90 triangle and our isosceles right triangle. What we're going to talk about now is how we can use that idea of those kind of patterns that we came up with for those two specific triangles to talk about any right triangle. And to do that, we need to come up with kind of these, what we call our trig ratios, which really are just different ways for us to represent those sides and kind of figure out what those patterns are in any right triangle. So there are three trig ratios. We're going to talk through each of those and kind of some different things that go with them. And then we'll talk into how do we actually use those to find missing sides and angles in a triangle. So before we get going into all of this, I have a quick note here at the top that says your calculator must be in degree mode. Most of them already are going to be. We'll talk about that a little bit more here in a minute and kind of show how you can test to figure out if your calculator is in the correct mode. Okay, but before we get to that, let's talk about these functions or trig ratios. So we have three of them. Like I said, we have sine, cosine, and tangent. And those are your three names that you see at the top of your table here. Okay, now each one of these gets a three-letter abbreviation. And if you're looking at these, you might see them on your calculator already. It is simply the first three letters of each word. So it is S-I-N, C-O-S, and T-A-N. Okay, now this is important that you know what these are. Yes, this looks like sin. We don't call it sin, we call it sine. We say the full word even though there's an abbreviation. Same thing with COS. A lot of people say cos. It's not cos, it's cosine. You need to say the entire word. Okay, same thing with tangent. It's not tan of a number, it's tangent. Okay. As far as symbols, right, there is a word that's associated, I would put word in quotation marks. It's not quite a word, but this phrase that we use to kind of remember sine, cosine, and tangent. Those are going to be S-O-H, C-A-H, and T-O-A. Okay, so SOHCAHTOA. Okay, so SOHCAHTOA is the word that we're going to use to refer to these. And the nice thing is that word, if you can get the word with the letters and everything else that goes with it here, you're going to know how to set up the vast majority of these problems. So let's talk about how these symbols that we just wrote down are related to the words that go with them. So let's talk about sine first. When we have our trig functions, there's always going to be an angle involved. That angle is what we're going to refer to as theta. Okay, theta is a Greek letter that we use to represent missing side or missing angle measures. If you want to make a quick note here, this is theta, which is for angles. Okay, and we're going to see that for each of these. So it's going to be sine of some angle. If I know it, I'll put the number in there. If I don't know it, I'll leave theta and I'll actually be solving for theta. Okay, now for sine, we use two sides and we set them up as a fraction. Now the two sides that we use for sine are opposite and hypotenuse. So what that means is if I have an angle, I'm going to actually jump to the picture here. If I have an angle, say I'm using the angle down here in the bottom, and I have my 90 degrees here as well, there is a side that's considered opposite of that angle, which you might be able to kind of figure out. It's going across our triangle to the other side. That's going to be what we refer to as the opposite side, or a lot of times we simply use the letter O to represent that. Then we have the hypotenuse. Well, hypotenuse we've talked about when we talked about Pythagorean theorem. That's always the longest side that's across from my 90. So this here is my hypotenuse. So if I knew these two measures, I would set them up in this equation. And what's going to happen is you're going to know two of the three things in this equation. You'll know either the angle measure on one side, or you'll know both sides, and you'll try and find the angle measure. Okay, by setting that up, that then gives us a way to solve for whatever missing piece we have. The same thing's going to work for our other two ratios as well. They just use different sides, and the reason we need those is if I didn't give you the opposite and the hypotenuse, you would have to use one of these other ones based on what sides I did give you. So it's just covering all of our bases. So let's talk about cosine next. We would have cosine of an angle, theta. That is going to equal A in H. So H is going to still be the hypotenuse. That goes on the bottom. and then A stands for adjacent. Okay, now adjacent, if I talk about my picture here, if I use that same angle that's in the bottom right there, I have my 90-degree angle. Adjacent is going to be the side that's directly next to my angle. So it's my side here that's along the bottom in this case. But I don't want to always think of it along the bottom because depending on where my triangle sits, it might not be along the bottom. Now, the other question that I get a lot here, well, if I'm talking about the angle or the side that's next to this angle, isn't this long side here also next to that angle? Which is true. The problem is it already has a name. The name that it has comes from being across from the 90 degrees, which is hypotenuse. So that name hypotenuse kind of trumps over any name that we would give it because it's the hypotenuse no matter what. So even though it is adjacent, it's not the adjacent side. The adjacent side is the other side that's next to it that's not the hypotenuse. Okay, so A and H, okay, cosine go together. Okay, they're kind of the two sides that form our angle that we're working with. Finally, we have TOA, or tangent, which is going to be tangent of our angle, which is going to be opposite on top and adjacent, adjacent along the bottom. Okay, so using two sides we've already talked about, but pairing them up in a way that we haven't had them yet. So if I have my same angle here at theta, and my 90 degrees across from my 90 is the opposite, all the way across my triangle, and then next to that angle is the adjacent. Okay, now I'm not going to use my hypotenuse in this case. Tangent is the only trig function that does not use the hypotenuse in any way. Okay, so these here are our three trig ratios. These three equations are going to be the three equations that I use on this entire set of notes and what you'll use for the entire homework that you have this week. One important thing here, just going back to these words, SOHCAHTOA. Okay, SOHCAHTOA, S-O-H, tells you what this ratio looks like. It's sine, that's the S, then O and H. O comes first, so it goes on top, H goes on the bottom. That's opposite and hypotenuse. Same thing with each of these. It's the trig value, the side that goes on top, and the side that goes on the bottom. Okay, and that works for TOA as well. So this SOHCAHTOA piece, if you know how to spell it out, is a great way just to kind of see these and use kind of a trick to get them. Okay, now let's actually start to work with some of these. The very first one here is a very simple question. It says we want to find the tangent of 26 degrees. Well, the tangent of 26 degrees is going to equal some number. And I don't even know what that number is. It's not really that important, other than it's going to help us find missing sides if we need to. And so what we're going to do is we're going to take and find the tangent of 26 using your calculator. So I'm going to grab my calculator here, and I need to type in the tangent of 26. Well, if you look on your calculator, you should see three buttons that look like they might be helpful here. You should have a sine button, an S-I-N, a cosine, a C-O-S, and a tangent, which is T-A-N. So if I want the tangent of 26, I simply type tangent, then I type my angle measure of 26 degrees, and I close my parenthesis and hit enter. When I do that here, I get a value of 0.4877. I'm going to go 4 decimal places on that. The reason for that is these values are very precise, and I want to make sure I keep that precision as I start to find missing sides and whatnot that come after this. Now, I want to talk about the calculator a little bit more before we get going. It's really important that you try this one on your calculator right now, because you could type in the exact same thing that I have and get a completely different answer. The reason for that is your calculator has two modes. It has what we call degree mode, which is what you need to be in. It also has what we call radian mode. That radian mode is something we'll talk about a little bit further into this unit. We need to stick to degree mode for now, though. So what I want you to do is everyone can type in sine of 90. Sine of 90 is just a test that we use. Sine of 90 always needs to be 1 in order for you to be in degree mode. So if you type in sine of 90, it needs to be 1. Okay? And you can think of this like a degree test. Okay? If it doesn't give you 1, then it fails the test and you're not in the right mode. So let's talk about how to switch it if you don't get that piece. Up here on my graphing calculator, next to the second button, there's a button that says mode. I'm going to hit that. And if you look at your third line here, I have degree and I have radian. You need to make sure that degree is the one that's highlighted. If it's not, if it looks like this, now radians are highlighted, I would just go to this line, hover over degree, hit enter, and now I'm in degree mode. Okay, if you're on the smaller scientific calculators, up towards the top here in kind of a similar place, you'll either have a mode button, just like I do, and you can again select degree, or sometimes you see a button that says RAD and DEG. That's again going from radians and degrees, and you can kind of hit that and it'll switch between those two. If you have any other type of calculator and you can't find that, shoot me an email. We can figure out how to get your calculator right mode. And once you have it in this mode, it should be good to go for a while, though. We're not going to switch modes for that for a while here. So let's go ahead and move on to number 2. Number 2 says at a location of 50 meters from the base of a tree, the angle of elevation to the top of the tree is 33 degrees. Determine the height of the tree to the nearest meter. A couple vocab things, or one vocab thing that we need to talk about there, is angle of elevation. An angle of elevation is measured from the horizontal. So from going straight across, it's how far you have to look up in order to see something. So here I'm talking about the top of the tree. You could also have what we call an angle of depression, which is the exact same thing, looking straight across, and then how far you have to look down to see something. So say I was on the top of a building or something and I'm looking down at a park. Okay, that distance I have to go down would be an angle of depression. But here we have the angle of elevation, and I did give us a picture here. I'm just going to draw in a line right through the middle of the tree here, because that's what I'm really being asked to find. I want to find the height of the tree. So I'm going to call this X. Okay, so that side X is what I'm trying to find. Now what I need to do is I need to figure out, well, what trig function is going to help me do this? To figure that out, I have to use the angle that I'm given, which is the 33 degrees here, and I need to figure out what two sides I know. Well, if I look, the side that I'm given, the 50, is going to be next to this angle. So this is my adjacent side. I know I'm going to be using adjacent. Then the other side I'm concerned with, I don't actually know it, but it's the side I'm trying to find, is X. Okay? In this case, I don't care about what this hypotenuse is at all, so I'm not going to use it. I'm going to use X. X is the opposite side from the 33, because I'm going all the way across my triangle. So now I'm using O and A, and now this becomes going back to kind of SOHCAHTOA, figuring out what side I'm talking about. Well, O and A is referring to tangent. Okay, that's the TOA piece. So I'm going to be using my tangent function here. So I start with tangent of my angle. My angle is 33 degrees. And I'm going to set that equal to a fraction. Now my fraction, if I go back up to the top here, is exactly what I have in words. It's the tangent of the angle, that's what I've already filled out, is going to equal opposite over adjacent. Well, my opposite side is the side I don't know. That's X. So I'm going to put X in there. But my adjacent side I do know. That's 50. So now I have this equation set up. Tangent of 30 is just a number, kind of similar to what we did up here in number 1. It's some sort of decimal. Again, I don't care exactly what it is. I'll type it in my calculator later. But I need to get the X by itself. So to do that, X right now is being divided by 50. So I need to multiply by 50 on both sides in order to get that X by itself. When I do that, I end up with X is equal to 50 times the tangent of 33. Now, if I can figure out what that is, that will be my answer. The nice thing is your calculator will help you do that. If I get out of my mode here, I'm doing 50 times the tangent of 33. And I simply type that in, I hit enter, and I get an answer of 32.47. Now, if I look at my directions here, I'm asked to go to the nearest meter. So the nearest whole number is the 2. The 4 is going to keep the 2 the same. So we're going to say that this is 32 meters. Okay, and that is my answer. Okay, so by using that trig ratio, that just allowed me to find one of my missing sides with only knowing a little bit of information. Okay, and what I just gave you here for this problem is a very realistic thing. I can measure angle measures fairly easily in the real world, and I can measure horizontal distances fairly easily. Vertical distances can sometimes be hard depending on what the object is, and so are kind of those hypotenuse distances kind of on those angles. So this kind of setup that I have here is very realistic of what we might actually see in the real world in a realistic problem. Now you may or may not want to know the height of the tree, but there are certain scenarios where that might be helpful. Okay, let's go ahead and move on though to number 3, and then my numbers skip around here. We're going to number 6 after that. Okay, so number 3 we have that we're trying to find the value of each of these for the triangle here to the right. So I'm asked for the sine of A, the cosine of A, the sine of B, and the cosine of B. What we're really going to talk about here is how these things change depending on the angle that we're referring to. So let's start with A and B here. Okay, if I start with A and B, they're both concerned with angle A. So I'm going to say that this here is the theta that I'm working with. Then I need to figure out sine. Well, sine is going to be based on opposite and hypotenuse. Cosine is going to be adjacent to hypotenuse. So let's actually just label all of our sides right now. Across from my angle here is going to be my opposite side. Next to my angle is going to be my adjacent. That's the 12. And then across from my 90 is the 13. That's my hypotenuse. So my O and A and H are all labeled there. Now I can set up my sine. Sine is so. Okay, if we want to think of SOHCAHTOA here again, it's SOH. So I'm using opposite and hypotenuse. My opposite is the 5, my hypotenuse is the 13. So I set this up as 5 over 13. I can then move on to cosine, which is going to be my adjacent and hypotenuse. So I use the 12 and the 13. And we set this up as 12 over 13. Now, I'm going to switch to a different color here because now I'm going to switch angles. I'm going to switch to angle B. Well, when I switch to angle B, I'm now using a completely different angle, which means that some of these sides actually change. So now when I go opposite of my angle, I'm at 12. So my 12 is now going to be my O. My adjacent side is now the 5 because that's next to my angle. But the 13, this stays as the hypotenuse. Okay, so that 13 is still going to be the hypotenuse, but my O's and A's kind of switched there. They flip-flopped. So let's talk about sine of B. Sine of B is now the opposite over the hypotenuse. Well, opposite is now the 12. Hypotenuse is still the 13. So this is going to be 12 over 13. And then part D, cosine of B, is going to be my adjacent over my hypotenuse, which is going to be 5 over 13. Alright, now I'm going to take a real quick second here just to point something out. Some of you are probably seeing it. If you look at your values here, you get the same values for all of these. You either have 5 over 13 or 12 over 13. Now, the way those pair up kind of makes sense. If I switch the trig value, I have to also switch the angle, and then I get the same value. Okay, so sine of A and cosine of B are the same, and cosine of A and sine of B are the same. And I can see that when I go back to my sides here, because what I do when I switch from sine to cosine, I'm switching from an O to an A. But when I switch angles, I'm also switching my O's and A's. So those kind of switch and then I switch back to keep us to the same value. Okay, that's actually what we refer to as a trig identity, that those are the same. We're not going to talk about those much this year, but you'll talk about those a lot more in the coming years. Let's go ahead and talk about number 6 here as well. We need to find the missing side length x in the triangle below. Again, looks very similar to the one that I did before. So we need to try and figure out what sides I have, and then we can go ahead and start to solve that. So I have my angle here. That's going to be what I'm referring to. So my 35 degrees is in the bottom right there. I need to figure out this 25. Well, that's definitely across from my 35 or opposite of that side. So I'm going to be using O there. And then I have this side X. Now that's my longest side or across from the 90, so that's my hypotenuse. So I'm going to be using O and H. And if I go back to SOHCAHTOA, which I have on the top there, I'm using S, which is referring to sine. So I'm going to take the sine of my angle, which is 35 degrees. And now this is really important. You have to set up this fraction the correct way. My fraction still needs to be O then H. Well, O is the 25, so that needs to go on top. And then on bottom is my X. Now, that's really important because a lot of times what we see is you always want the variable on top, which I agree with. That's a lot easier to deal with, but it's not correct. This is the correct way to set it up. Now, because the variable is in the bottom of that fraction, I have to be very careful how I solve this. When I have anything in the bottom of a fraction, whether it's a number or a variable, the first thing I'm always going to do is multiply by that piece that's in the denominator. So here I am going to multiply by x. Even though I'm trying to solve for x, I'm going to move it to the other side, and you'll see why here in just a second. I have x times the sine of 35 is equal to 25. So what I just did is I got rid of the fraction, which is important because now I can get x by itself. I was not able to get x by itself when it was in the bottom. What I can do now is the sine of 35 is just a number, and it's being multiplied by x. So I need to get rid of that number. The way I get rid of it if it's multiplying is divide. So I'm going to divide by the sine of 35, which is a little bit weird. Some people don't like the fact that we divide by a function like that, but we're allowed to do that because it really is just a number. It's the same thing as taking a 2x and dividing by the 2. It's just in a different form here. So now I need to type this into my calculator because x is now by itself. Whatever I can get from my calculator here will give me my answer. So I am trying to type in 25 divided by the sine of 35. So I'm going to do 25 divided by sine 35. Close your parenthesis there and hit enter. And you get 43.586, which, just want to verify here, is my correct answer. And I'm going to go 1 decimal place here. So I'm going to go 43.6 for my answer. Okay, for our missing sides, we typically are going to go to 1 decimal place unless we're told otherwise. Like that tree problem that we did told us nearest meter, so we went to meter. But typically we're going to round sides to the nearest tenth or 1 decimal place. Okay, now I'm actually going to stop this video here. We do have some more trig to talk about, and we'll get into that in a second video in just a minute.